Okay, today we are going to work with the parallel lines. Let's go over here to our learning goal. I can identify and graph. Well, today the only graphing you will do will be with the graphing calculator, so we'll get to see the relationship on the calculators. So you're going to identify and graph parallel lines, and you're going to be able to write an equation to describe a line parallel to a given line. That's probably the more challenging of the two learning goals, being able to write an equation for a second line that would be parallel to a given line, and it has to pass through a certain point. So we'll be doing that on the back side of these, okay? So let's start with a non-vertical lines. With your arms, show me vertical lines. What do vertical lines look like? Show me with your arms. Okay? Straight up and down, right? Okay, so non-vertical lines. So now, you have to put your arms in a form that's non-vertical. Something that's not vertical. Non-vertical lines. Okay, so if we have non-vertical lines, and they will be parallel if and only if they have the same what? What do you think they'd have to have the same? They'd have to have the same slope. They would have to be rising and running at the same rate. As long as they are rising and running at the same rate, they should be parallel to each other. What does parallel mean?
They never cross.
They never cross, they never meet, they're always the same distance away from each other, yeah. So if we have parallel lines, they have to have the same slope. What has to be different then? The y-intercept is going to have to be different because they can't have the same slope and the same y-intercept, because if they did, what would be the case? It'd be the same line. It would be a line on top of another line, it would be the same line, right? So any non-vertical line, any non-vertical lines would be parallel if and only if their slopes are the same and their y-intercepts are different. Well, what if we have a vertical line? When are vertical lines parallel? So what a vertical line is parallel to? Another vertical line. That's the only thing it will be parallel to. But there is a restriction there too. How do we not have the same vertical line? Different what? X-intercepts, because vertical lines cross the x-axis, not the y-axis. So as long as they have different x-intercepts, then we will have parallel vertical lines, okay? So we don't talk about slope with vertical lines, right? What's the slope of a vertical line? Undefined. So vertical lines really don't have slope, so that's why they kind of have their own category. Vertical lines are parallel to other vertical lines, and when they have different x-intercepts. Okay, on page 297, everybody go to problem number 2. Look at the directions for that set of problems. Ask you to have your books open to page 297. What do the directions say you're supposed to do for problem number 2?
Identify which lines are parallel.
Identify which lines are parallel. Okay, so what do they give us?
The y.
What do they give us?
Y equals x plus b.
They give us equations, right? Y equals something, and then like y equals 6. Is that one of them? Yeah. Haley, what's the next one? Nope. Skipped over one.
Y equals 6x plus y.
Okay. Could you sit up and engage for me, please? Okay, how many equations are there? 4. There are 4 of them. There are 4 of them. I have already written them down for us right here. Tell me something about all 4 of these equations that I've already written down from the book. What form are they in? Slope-intercept form. So if they're in slope-intercept form, that's good news for us because we do not have to then do any more work. All we have to do is, and by the way, this is what you do have to do though, you have to identify the slope and the y-intercept to support which lines you say are parallel. So we're going to identify the slope and the y-intercept for each of these. What's the slope of the first one? Y equals 6. What's its slope? 0. When there are no x's, that means 0 times x, the x's were washed out. They were cleaned out. What's the y-intercept? 6. It's going to cross the y-axis at 6. What kind of a line do we have here? Okay, let's go to our graphing calculator and put it in. Let's do it. So y equals, if there's anything in the y equals, if you have any plots darkened across the top, raise your hand so I can tell you what to do. Any of those plots, 1, 2, or 3 across the top are dark? No? Okay, so everything should look kind of like a gray screen. There should be nothing darkened, no equations in there. I should just, yep, that's a darkened one. Cursor up onto that plot, Brady, again, press the enter key and it'll turn it off, and then you can jump back down to y sub 1. Okay. So, okay, in y sub 1, they already have the y there for us. We do not have to type that. We just have to type the function rule. And the function rule for this one is 6. So put a 6 in there. Okay? Let's do a standard window, which we only have to do this one time. From here on out, we should just be able to press graph. But this time I want you to press a zoom 6. Zoom 6. Okay, tell me, what kind of line do we have? A horizontal line. So remember I said we need to get it memorized, planted, somehow remember that when there are no x's in a linear equation, we have what kind of a line? A horizontal line. Every y value on this line is what? Every y value for every point on this line is what? 6. Yeah, it still has x values, but every y value is 6. So we, seriously, I really need you to. You're not going to do well if you do not get this figured out, that when there are no x's in a linear equation, you have a horizontal line. Okay, do a second on and turn that off for right now. Okay? How about our next equation? Y equals 6x plus 5. What's its slope? 6. And its y-intercept is 5. Are these two lines parallel? Why not? What? They have different slopes. They have to have the same slope, don't they? How about the next one? What's its slope? 6. And its y-intercept is? -7. Okay. How about the next one? Slope of 0 and a y-intercept of? -8. Okay. Do we have any sets, whether there's 2 in the set or 3 or all 4 or whatever? Do we have any sets of parallel lines? We have 2 sets of 2. Okay. Which ones are they? The first and the last are parallel. Okay, so here's how we will write it. Y equals 6 is parallel to, that's the math symbol, 2 vertical line segments, is parallel to the last one you said, y equals -8. Okay, prove it on your graphing calculator right now. Turn it back on, and in y sub 2, put the y equals -8. Remember, you don't have to type the y, you just have to type the function rule. This one's function rule is -8. Careful, listen to me. The subtraction key is for subtracting. There's a negative key down by the enter key that is for negative. You have to use the appropriate one or it's not going to work for you. So y sub 2, we're putting -8. Press graph. You have 2 lines that are parallel.
Yeah.
Therefore, we have another horizontal line. So apparently horizontal lines are parallel. Does that make sense that they would be? Yeah. Okay. Do we have any other parallel lines in this grouping of 4 equations? The middle two. Because what? The slope is the same. And their y-intercepts are different. So let's write that down first, that we have y equals 6x plus 5. Parallel to the y equals 6x minus 7 reasoning. Same slope, different y-intercepts. They should be rising and running at the same rate, crossing the lines at different locations. Now I want you to go in and type those in. You can put them in 3 and 4, or you can clear out 1 and 2, whatever you want, doesn't matter. Put in 6x. Where's the x key again? Next to the, it's next to the alpha key. It's green, they're right next to the green key. So put in 6x plus 5 and 6x minus 7. And I really truly want everybody, making sure you can make this happen, because once you leave algebra, they expect you to know how to use these graphing calculators. They're not going to teach you. So we're in y equals, not anywhere else. Y equals, you type in these two equations. After you've typed them in, you can press graph. And according to the slopes, you should have lines that are rising from left to right. One should be crossing above the x-axis, and the other one should be crossing below. Am I right?
Yes.
Okay. So they are.
How do you guys do this?
Got so many lines on there now, it's hard to tell, isn't it? Yeah. So if you didn't clear out 1 and 2, you probably have between. You have the axes, you have those 2 horizontal lines, and now you have 2 other lines. So you got all kinds of them going on there. Just if you want, you can go in and just clear out 1 and 2, and then press graph again, and you'll only have these last 2. Okay. You don't want quite so much busyness on the screen. Okay, so I want us to, when you're doing your homework and you have to identify parallel line relationships from equations, I do not want just the relationship saying these guys are the ones that are parallel. What else do I want? Explanation. How is your explanation going to look? Since you're not probably going to record it and send it to me. Identifying and don't say same slope and different y-intercepts. Actually identify them, right? Identify, show what the slopes are, show what the y-intercepts are, because you're going to get caught sometimes thinking lines are parallel when they're not. They end up being actually the same line, because you didn't spend enough time checking out both things, the slope and the y-intercept, okay? So questions, anyone? Okay, turn that calculator off again. We're not going to use it until we get to the back section. Okay, number 3. This is from the book also. I've already written down the equations for us. We're in the same part of the lesson. Identify parallel lines. So the first equation, y equals 3/4 x minus 1, is in slope-intercept form. Ready for us to identify slope and y-intercept, right? Let's do it. Second equation, y equals negative 2x. Ready for us to identify slope and y-intercept? Okay, slope is? Negative 2. Y-intercept is 0. There's nothing being added or subtracted, so that means a 0 got cleaned up out of it. It's a plus 0, but it got cleaned up. How about our next equation? It's not in slope-intercept form. Do we need it in slope-intercept form?
No.
Why not? What do you think? Do we need it? What can we get from point slope form? We get the slope. How many points? 1. From a point slope form equation, we get the slope and a point. Well, as long as that point is what? Is it good to say, well, I can just identify it? What does that point need to be? So what? No, a point can't be a line. What does that point need to be? If you're not gonna rename this into slope-intercept form, what better that point be then, so that you can say, I am confident that I have a line that is parallel to another one. They gotta have the same slope. Well, we can get the slope out of it, can't we? Okay, let's identify. What is slope? What is the slope? 3/4, it's right there, okay? Is that all we need? Is that all we need? No, what else do we need? We need the y-intercept. Can we get the y-intercept from this right now? Only if what? X from the point is equal to 0. Is x equal to 0 from this point? What point is being represented in there? What ordered pair is being represented? Ordered pair 5, 3. Is that the y-intercept? No. Guess we're going to have to work harder. Okay, let's get it into slope-intercept form. Let's go. y take away 3 equals 3/4 x minus 3/4 of 5. Guess I'll come over here since what is that? 15 over 4. And 15 over 4, what's 15 over 4 equal to? This is a y-intercept, so when it's a y-intercept, we can change it to a mixed number. What mixed number is that? 3 3/4. Okay, cool, let's go with that. Okay. Is that our y-intercept, or what else do we have to do? Are we done? No, what do we have to do?
Y by itself.
Get y by itself. How are we going to do that?
Add 3 to both sides.
Add 3 to both sides. So y is now by itself. 3/4 x is going to stay 3/4 x. We have a negative here, because if I change that to add the opposite, I really have a negative 3 3/4 plus a 3. 3/4? Negative 3/4. Negative 3/4. So in reality, we have y equals 3/4 x minus 3/4. Now we can say, oh, our b value is negative 3/4. Nothing says intercepts have to be integers. It's because they both start with int. Okay, carry on. Here's our next one. Y minus 4 equals negative 2 times x plus 2. Point slope form, right? What's the slope?
-2.
Negative 2. What's the ordered pair that's being represented in that one? Nope. What is it? Negative 2, because we would really need to change this to subtract the opposite. That's a negative 2. And what's the y value? Is that the y-intercept? Is that the y-intercept? No. Okay, well, I guess then so much for getting to take the easy out. Y take away 4 equals negative 2x plus negative 2 times a positive 2 is a negative 4, right? All right. Okay. Now we're going to do what? Add 4 to both sides to get that y alone. And our equation is, the slope-intercept form name for that equation is? Y equals? Negative 2x. These guys cancel each other out. What's our b value? Okay, I think we finally have enough support to make an informed decision. Do we have any sets of parallel lines? Same slope, different y-intercepts. Okay, these guys go together, by the way, right here. These guys go together. And these guys go together. And then, of course, these guys are already together on a line. Do we have any sets of parallel lines? Yeah? Okay, what are they? Which ones? The first, second, third, or fourth ones? The first and the third. They both have a slope of 3/4, and they have different y-intercepts, don't they? Okay, so let's go ahead and write that down. Y equals, I gotta scroll back up, I guess. 3/4 x minus 1 is parallel to, by the way, in an answer bank, they are not going to give the slope-intercept form name. They're going to give its original name. So if it is parallel to the third one, we have to write it as its point slope form name, because that's how it will be in the answer bank. So we're going to go back to its original name before we renamed it to make sure that it had a different y-intercept. Any others? What about the second and the fourth? What's true about the second one and the fourth one? They're the same slope and same y-intercept, so they are the same line, aren't they? They're the same line, so we only have one set of parallel lines this time? Yes, no, maybe? Okay, thanks. Questions? You do something like this in your homework. This would be your guide for knowing how much work you need to show. Okay, let's go to the back. And we are going to work with problem number 4 now in that same set of problems, but now I don't have any information written down on the sheet for you. So you gotta look at problem number 4 in your book. I believe it's telling us to prove that ABCD is a trapezoid. Am I right? What's a trapezoid? It's like a crazy gymnast. First of all, it's a how many sided figure? 4. So that makes it a quadrilateral. So it's a quadrilateral with one set of parallel sides. And of course, for them to be parallel, they gotta be opposite each other, right? They either gotta be opposite each other going this way or opposite each other going this way. And then the other set are not parallel. So for us to prove that this is a trapezoid, we would have to prove that there is a set of parallel sides. Okay? Can we tell already that they have a different y-intercept? All of them? Every line on here has a different y-intercept? Yeah, it does, doesn't it? Every side? Okay, so which two line segments appear to be parallel? AD, okay. Line segment AD, and that's how we write it. And which other one?
BC.
BC, okay. So it appears that those are parallel, but next year in geometry, no appearing gets to count. You have to prove everything. So that's what we're doing right now. We are proving that these are parallel. So show that they have what then? How are we going to prove that they're parallel? They have the same slope, yeah. We just need to prove they have the same slope. We can prove the same slope, then we can tell already from the picture that they have different y-intercepts. So I'm not going to make you figure out their y-intercepts, but you do have to figure out that they have to show that they have the same slope. So let's start with a line segment AD. What are the ordered pairs for point A and point D? Help me out. I don't have my book open. I'm counting on you.
-2, 5, and 2, negative.
And 2 what? -1. Okay. Do we know how to find slope given 2 points on the line? Okay, then do it. Go ahead. You know how. We better all get the same slope in the end. We might have reversed the order. Let's get the same slope. What is the slope? -6/4, which simplifies to -3/2, right? So we're going to pull the negative sign out front. When just one of the numerator or the denominator are negative, it makes the fraction negative. So the slope of this line segment is -3/2. Okay, let's do line segment BC. Let's find its slope. What are the ordered pairs for B and C?
4, 5,
4, 5?
6, 2.
6, 2? Everybody agree? Okay, don't make us work hard and then we have the wrong points to start with. You know, like when I mislead you guys. Okay, find the slope of that one. I got -3/2. Anybody else? So what does that tell us?
Question.
Good question, okay. It tells us that AD, line segment AD, is parallel to line segment BC. Therefore, A, B, C, D, quadrilateral, A, B, C, D, is a trapezoid. Yes, Carter?
Could you get them either positive or negative? Because, like,
No, they have to have, because what's happening on the graph? Aren't they falling from left to right, Carter?
yeah, but they can all, yeah, never mind, I see yeah.
What's going to be different, Carter, is this. Up here for AD, if your 4 was negative instead of your 6, that could be. If down here your 2 was negative instead of the 3, that could be. But either way, the slope has to be negative 3 halves, okay? Questions? You hear me on this. In your homework, everybody look at problem number 12 in your books right now. Problem number 12. In your homework, because this happens all the time. It's like, well, we only had to find the slope of 2 sides in our notes, but what are they asking you to do in number 12? Another trapezoid problem? What is it? You have to prove it's a parallelogram. What's a parallelogram? Well, all 4 sides can't be parallel. Come on, people. You're going to have quadrilateral then.
2 sets of 2.
You have to have, yeah, both sets of opposite sides have to be parallel. These sides have to be, these sides have to be, for it to be a parallelogram. So how many slopes are you going to have to find? 4. You're going to have to prove that one set of opposite sides are parallel, that's 2 slopes. You're going to have to prove that the other 2 sets of opposite sides, the other set of opposite sides are parallel, that's 2 more slopes. Will those 4 slopes be the same? No. 2 of them should match, and the other 2 should match, and if they do, you can say it is a parallelogram, yeah. Okay, so in your homework, you're going to have to work a little bit harder than we did here. Okay, moving on to the most challenging usually. I want you to go to your graphing calculators right now, and I want you to put in y equals, I want you to clear out everything else that's in your y equals, please. Clear out everything else, we don't need a bunch of extras. Clear out the stuff you have, and I want you to put in 1/2 x plus 5. Now, I want us to learn how to put these in as fractions instead of decimals because not all fractions are nice decimals. So I want you to do parenthesis, 1 divided by, and I'll do a fraction bar, 2 parenthesis. Don't even move on till you have that. 1 parenthesis, 1 divided by 2 parenthesis. Now type your x plus 5. What should we, don't you hit that graph key yet? What should we expect? This line should be what? What's a positive line? A line that smiles? It's rising from left to right. And what else do we know? We know that the y-intercept, we know it's crossing the y-axis at positive 5. Okay, I need you to, right now, I need you to put just a rough sketch of what does that look like on your graphing calculator. I don't know. Is it very steep, by the way? Oh, graphic, go ahead. I'm sorry, I guess I forgot to let you graph. Press graph. Is it very steep? No, it shouldn't be because it has a slope not very far away from 0, so I guess I should do a better job. Okay. Okay, so now I need you to make the connection. Okay, I need you to hear me on this. Here's what you're doing in this section. You're not going to be graphing in your homework. You're not going to have the graphing calculator. But what's happening is the instructions tell us to find the equation of the line parallel to the given line. This is the given line you just graphed. We need a line parallel to that one, but there's a little catch. It can't be just any line. It has to be a line that goes through this given point right here. So, well, how are we going to make that happen? How are we going to get an equation for a second line, a new line, that's going to be parallel to that one you have in your graphing calculator right now, and at the same time, it's going to go through ordered pair 4, negative 3. Carson?
Altogether, the negative 3 for y and 4 for x, and then the 1/2 is the slope.
Well, why is the slope 1/2? Oh, it has to be parallel to this one, and this one has a slope of 1/2. So would you write that down? That's important. We have to take that information from the given line and say, you know what? If your slope is 1/2, on the new line, I have to have the same slope. So Carson's right. We have to have a slope of 1/2. We know an x value, we know a y value. Do we know how to find a y-intercept? No. An equation? No. Sure we do. We can use point slope form, or we can use slope intercept form. So you pick which one you're going to use. I'll do mine, you do yours, okay? I'll use this one today. After you get your equation, don't count on me, Beamer. You know I screw up all the time after lunch. Go, after you get your equation, go put it in y sub 2 in your graphing calculators. After you get your equation, go put it in y sub 2 of your graphing calculators. Check yourself out. Got it? Press graph after you get it in and see if you have a set of parallel lines. Remember how we put the 1/2 in? By the way, I happen to know I'm right. If you're like struggling getting this, you can copy me. Do you have parallel lines? Oh, but wait a minute. Just now you're feeling so good about yourself, you got parallel lines. What else has to be true? Well, yeah, they wouldn't be parallel if they didn't have different y-intercepts. What else has to be true? They said, write an equation of a new line parallel to the given line that passes through ordered pair 4, -3. We have to check to make sure it's passing through ordered pair 4, -3. How are we going to do that? Well, here, I'll tell you. Second graph, go to the table, second graph. Go to where x is equal to 4. Go look at your y sub 2, that's your new line, is y -3. You need to be doing this, don't pretend. I can't run around and make sure 20 of you are doing it, so do it. Is ordered pair 4, -3 on the new line. If you need help with the graphing calculator, get your hand up. Miss Olson or myself will come and help you, but okay. Okay, so parentheses 1 divided by 2 parentheses x plus 5. Okay. So now you're gonna do the 1/2 x minus 5.
It is.
So you divided by this.
I'll divide.
Divided by this slash for you. Go to second graph to go to the table and make sure that our line is going through. So go to where x is 4, is the y dot we make it 3. Yeah. Yeah. So it's passing to the point it needs to. Okay. Do you think any other line parallel to the first line would go through ordered pair +4, -3? Would any other parallel line to the first line, would it go through this point? No, we can't. So if we have the right equation, then that point better show up in the set of ordered pairs that make that line. Okay? Questions? So when you're doing your homework and you have to do this, you need to visualize what is happening. So what is showing on your graphing calculator right now, I believe, is something like this. You have, let another blue line. You should have parallel lines. One's crossing above the x-axis, the other one's crossing below the x-axis. Am I right? Yeah. So you just found the equation of this line right here. This is the one you just found the equation of. That was what they were asking us to do. Okay? Okay, let's do the last one that we have. We're running out of time here. Tell me something about number 33. What's the problem here? Can you get the slope from that? Oh, don't we need it? Okay, what are we going to do? We're going to get y by itself. Yep, go ahead. Make it happen. Why did we do this? Correct. We need the slope. What's the slope? -3/4. All that to get that. Okay, now that we got that, big deal. Now what? We have to write an equation for a new line parallel to this line. That's going to go through, oh, it just happens to be the same point. No, it doesn't mean it'll always be, but it just happens to be this time. What are we going to do? What's the slope of this line? -3/4. It's parallel to that other one. It has to have the same slope. So now we can do our, I think this time I'll use point slope form just to be different. If I need to clean that up. And then unclean it up on the other side. Now I gotta do distributive property. Okay, seriously. Y plus 3 equals -3/4 x. What's 3/4 of 4? 3. And a -10 to negative is a positive. Okay, well, I think there's still one more thing to do. That would be subtract 3. I get y equals -3/4 x. Anybody else get that? Anybody use the other method, the slope intercept form method, and get the same thing? Cool. Okay. Well, then we can trust that this is the correct way. We're not going to graph this, we don't have time. So, would you, if your calculator has not turned itself out, or you have not turned it out yet, will you put the covers on properly? If you have to push the cover on, you're putting it on improperly. Okay. So, I'm going to throw them back in the graphing calculator case and get the assignment written down.
I'm sorry.